So, here let us look at the topic modeling part. So earlier we saw the query related stuff, right. So, in the transform domain we are able to query based on the keywords, and the related documents are retrieved using some similarity values. So, in this case we are going to be looking at a different corpus. This corpus contains about 5 different topics. It contains topics related to business, entertainment, politics, sports, and technology. Okay, there are about 5 topics, and the total document count is about 2225, and this corpus contains about 27,750 unique tokens. Okay. The normal setup, especially in the case of GenSim, if you do not provide any values as part of the model, it will take the k value as 200. So, in this case I am just taking the k value as 200, and then I am going to be keeping 25,000 words. So, our matrix size is going to be 25,000 by 200. Okay. So, that is your original term document matrix. Again, in this case I am computing the TF-IDF, and I have added little more additional functions for the pre-processing. One is I am taking off all the numeric using this strip numeric function. I am removing stop words given by the GenSim. You may also want to add your own stop words to this, and then I am going to strip words which are smaller than 3 or smaller than or equal to 3, and I am not stemming it. I am removing the punctuations. If there is any tag that are available as part of the document, that is also being removed. So, the pre-processing does all these tasks and then returns a set of tokens. Okay. It is very similar to what we saw earlier. Okay. So, we have done the pre-processing. Again, for your convenience, I have kept the corpus which you can pick up from this particular location. Okay. So, again I am keeping 25,000 words, and I am not using the standard one that we used earlier. So, there we use the number of topics as 15, right, in the previous problem. So, here I am not specifying anything. We can specify that as well. I am just leaving it as is to the default value. I am going to see how it is defining these topics. The idea in this particular demo is to find out the number of topics in the given corpus. So, nowhere we have specified the number of topics except in the last one, where we are restricting the number of topics that it wants to list, right. So, once we have set up the text and then created the model, so we can print the topics where we can pick up how many words you want in terms of describing the topic. So, again that is a variable that you can change. So, here there is a variable that you can change. Here the number of tokens, the number of topics that you can change. Num topics here refers to the k in the eigenmatrix. Okay. And then we are going to be printing only 5 topics, and each topic will contain 25 words. So, I have computed this earlier for you, and we can find out there are 5 topics printed by this application. The first one corresponds to, let us find out to what. So, it has labor, election, Tony Blair, I think, Brown, government, party, people, tax, film, economy, music, new minister, mobile, game, chancellor, growth, world, games, and so on, right? So it contains lots of words that you will find in the politics as well as in the entertainment and music. Okay, let's see what it has done to the second one. So we have Labour, election, Blair. You see the values being small, right, in the negative side. So again, it is not very clear. It has not picked up the class very clearly. Let's look at the third one. There is a growth, a billion, sales, economy, island, broadband, market, phone, rugby, cup, digital. You can see even the sports related things are being mixed up in this, right? And then let's look at the fourth one. So far we are not very successful in terms of finding out the right class. Let's look at the last one. Film Best Awards, England Award, Music, Oscar, Growth, Actor, Economy, Actress, Aviator, Island, Wales, Films, Festival, Robinson, Nominated, Nominations, and so on. So we can see a lot of terms related to the entertainment. Let's look at the last one. We have mobile, billion-dollar economy, phone, digital, bank, Microsoft, users, broadband, economic, people, award, technology, Oscar, and software. Again, there's a mix of both entertainment and technology in this. So how do we fine tune this? So the way you want to do is, I'm going to leave this again as an exercise that will also help you learn this library. Keep changing these values here, n, and then here the number of topics, the number of words. So let's see if I can reduce the number of words to, let's say, 10 and see what happens. Okay, so I have used the same one. I think there was some issue with respect to logging in. So let me again go through the or is it similar? Yeah, it is same. Yeah, it's same as what we saw. Okay, let's change the values. Instead of 15, 25, let's make it 10. So this is somewhat better, because the number of terms are less. So here in the first one we see Labour, election, Blair, Brown, government, party, people, tax, and film. I think most of what we see here is related to election or politics, right? So let's see the second one: Labour, election, Blair, Brown, party, tax, chancellor, Howard, film, and Tory. This looks like more than what we saw there again, right? The third one we see, again the first two are not very clear in terms of identifying which class it really belongs to. Look at the third one. We have, we just look at only the positive ones in terms of the weights. England, Wales, game, win, best, right? So game and win, England, Wales, maybe it's sounding like sports. Let's look at the fourth one, film, best, awards, award, music, Oscar, actor, economy, right? So if you look at the positive ones, we have film, best award, music, Oscar, actor. So it could be related to entertainment. Let's look at the last one, the film, best, dollar, economy, UCOS, growth, phone. Maybe it is both business and some technology aspect into it. So by reducing the number, right, we can see the words that are contributing to that. By keep changing the values here, right, instead of keeping 25,000, keep only about 10,000 and then see how it does. So by fine tuning this, you will be able to get to some optimal class for the given data that you have provided. So it is not perfect, right? It is not really a good classifier. No, it's not able to really do a great job in terms of doing the classification because of a lot of noise that you find in the text. The noise comes because of the large number of vocabularies that we have, and many of them only have about very small contribution with respect to the frequency or TF-IDF. So that could be one of the biggest problems. The reason stems from the fact that when you look at the sigma values, okay, let me go back to, so the sigma values, if you look at this for the BBC text, the sigma 1 equal to 6.23, and then if you look at the sigma 200, it is equal to 1.3. See, that is the problem, correct. So if you had seen in the image demonstration, the sigma values of the last one is very small, very negligible. Here there is a contribution. The contribution comes because of the lot of vocabulary words, a lot of words in the vocabulary that don't have a lot of frequencies. That's why we are not able to really find the patterns. But if you have more number of patterns, the values here in the sigma would be very small. Okay. So we can say that because of the noise factor involved in the document, we are not able to really classify it in a clean fashion. So how can we do that? How can we do this job better? So that's where we have to go and then look at the corpus and then find out what kinds of words that are contributing to each one of those. Maybe even in the case of the classification, right, what they had provided, they probably would have classified, since they are all manually classified, and there could be some error there too, isn't it? And then if you look at the sports and technology part or business and politics, there could be a lot of words that are available as common words. So that could also be one of the reasons why it is not really doing a great job. Other parameter that I have noted is it contains about 30,000 nouns. So it contains 27,750 unique words, and then if you look at the noun count, it is about 30,000, not 30,000, 309,421. Okay. So that's the total count. So what we have done is we have taken about 25,000 into 200 as our matrix size, and still because the contribution of this sigma all throughout is really corrupting our application. So how do we get this reduced? Only if you are able to capture a lot of pattern that are represented by the first one, right. So you will be able to do a reasonably good job. So, for us to do this, the job is to make sure that we are trying to reduce this, and the contribution of this sigma is pretty small when it goes beyond the points. For example, if you are able to cut it to, let us say, 100, the contribution from 100 to 200 should be very small and insignificant, whereas in this case it is not so. And also the sigma value reduces very slowly. If you have this as 200 and this is 6, right. So, it is like this. Shouldn't be the case. So, it should be like quickly it should decay down. Okay. So, what I suggest is take a close look at many of those documents and then see what we can do to improve this. So, that is the first step. So, you need to really look at that and then see what kind of pre-processing that we can do. So, looking at the corpus closely is always about finding out how to do the pre-processing and eliminate certain noisy things that are not really going to contribute to our process. And then second one is look at the parameters that you have that I have shown, and then see and then try to fine tune them one by one, and then see how they really contribute to the application. Okay. All right. So, with this we conclude this session on word to vectors.